Hello my friends, I hope you're feeling fantastic now after this first data preprocessing phase that we tackled in a flashlight together. Now we're ready for the exciting step, which is to train the multiple linear regression model on the training set that we now collected thanks to the previous step. But first, before we do this, I would like to answer two important questions. The first question is, do we have to avoid, to do something to avoid the dummy variable trap? And the answer is no, because indeed the multiple linear regression class that we're about to import and which will build the multiple linear regression model itself and actually also train it, because remember that a class actually can complete several actions, including building it and training it, and well, this class will automatically avoid this trap, which means that indeed, one of the three first columns here, because remember Kirill explained that one is redundant, well, will automatically be outcast. So you have nothing to worry about regarding the dummy variable trap. You don't have to remove one of the columns here. And that's the beauty of classes. These are advanced implementations that allow you to build a model, a machine learning model, in just a few lines of code. And this will take care of the dummy variable trap for you. Now, second question, do we have to work on the features to select the best ones with, the techniques that Kirill introduced to you, like, for example, backward elimination? Do we have to deploy the backward elimination technique in order to select the features that have the highest p-values and that are the most statistically significant? And the answer is, once again, no. Why is that? Well, for the exact same reason as the dummy variable trap. The class that we're about to call to build our multiple linear regression model will automatically identify the best features, the features that have the highest p-values or that are the most statistically significant, to figure out how to predict the dependent variable, the profit, with the highest accuracy. So, once again, you don't have to worry about this. The class of scikit-learn, this amazing data science library, will take care of everything for you. Okay, so I'm glad I answered these two questions. The purpose of building machine learning models today is to be efficient, because in your career, I can't tell you how many times I had to test several machine learning models on my data set and select the best one. Well, if I had to deploy the backward elimination technique on my data set, well, I would have lost a lot of time. And here we have a class that takes care of everything. You just have to deploy your class on your dataset, and then you will get an accuracy, and you will compare that accuracy with the accuracies of other models. And that process is called model selection. That's what we actually cover in the part 10 of this course. So really, I want you to be efficient with your implementations and your machine learning toolkit so that you can optimize your model selection process. Alright, so now that we said this, well, let's build together the multiple linear regression model. And now actually I have some good news, because, we're still doing linear regression. And in the previous section, we actually did simple linear regression, with which we therefore had one feature in our dataset. And now we're doing multiple linear regression, which is exactly the same as simple linear regression, except that we have several features. So the good news is actually that the class that we're about to use to build and train this multiple linear regression model is actually the exact same class as for the simple linear regression model. It will just recognize that there are several features and therefore that we are doing multiple linear regression, but the rest will be exactly the same. It will be trained to understand the correlations between all your features, actually I can open it here, all your features and the profit, which is your dependent variable, and then it will take care of the dummy variable trap, and it will also take care of selecting the best features that are the most statistically significant. So that's the good news, but still, I just want to re-implement this again from scratch to make sure it is best integrated in your head. Alright, so let's close this and let's implement our multiple linear regression model. Actually, try to do it faster than me, try to do it before me, you can press pause on this video and do it. And me, I'm gonna do it pretty efficiently. So remember, we have to start from the sklearn, the scikit-learn library, from which we're gonna get access to this specific module, which is linear model. There we go. Google Colab guesses it perfectly. And from this module, we're going to import, well, the linear regression class. Google Colab guesses again perfectly. Alright, so that's the exact same class as in the previous section on simple linear regression, And there you go, we're going to do just exactly the same. This is exactly the same code as what we did in the previous section, because now we're going to create a new variable which will be our multiple linear regression model, which will be created as an object of this linear regression class. So let's introduce this new variable, regressor, equals, well, since this will be an object of the linear regression class, I'm just copying this class and pasting it here and adding some parentheses. All right, so that regressor is created as an instance of this linear regression class. Now the question is, do we have to enter any parameters here? Well, just like simple linear regression, the answer is no. We are just going to keep the default values of the parameters inside this linear regression class. I will explain in a whole section parameter tuning, when you can improve your model, but for linear regression it's pretty simple, so usually we don't have anything to input here.